Okay, so note 7.5, we're going to be looking at quadratic application problems. So basically the quadratics that we've been going over these past couple of units, we're going to be applying that to the real world. So on this first example that we have, it says Vinny Testaverde is standing 40 yards from the goal line when he throws a pass towards the end zone. The equation that represents the path of the ball is y equals negative 0.0975x squared plus 3.9x plus 6. X is going to represent the number of yards from the goal, and your Y will represent the number of feet the ball is above the ground. Okay? Alright, so what you're going to have to do is you're going to have to adjust your windows on these, okay, in order to see your parabola. Now, we're talking about real world situations here. So our X represents the number of yards from the goal. Okay, we're not going to be negative. We're not going to be dealing with any negative X values. So let's go ahead and say that our X min will be 0. And then on your Y, the Y represents the number of feet the ball is above the ground. So our Y min will also be 0. Okay? Alright, so let's go ahead and plug it into our calculator. So we have negative 0.0975x squared plus 3.9x plus 6. Now remember when we were going over quadratics, that C, your constant, is your y-intercept. So we know that it's going to cross the y-axis at 6. Now notice, if we don't adjust our window, we see a line. We should not see a line. We should see a parabola if we're looking at the entire graph, because this is a quadratic. Okay? So we're going to go ahead and go to the window. My X min, we already said we want to set at 0 because we're not going to be looking at any negative yards. And then same thing for your Y min. We're going to set that at 0 because we're not going to be looking at any negative numbers for our feet the ball is above the ground. Okay? Alright, so let's think about this. Our X represents the number of yards from the goal. We know that he's standing at the 40-yard line. So let's change our X max. Let's just say 50. Okay? Now, whatever you set your window to is how I want you to graph it on your paper. I don't want to make this X scale here, I don't want to make 50 marks. Okay? So I'm just going to increase by 10. And then my Y max, Y is the number of yards, number of feet the ball is above the ground. Okay, so let's go ahead, let's just say 50. We'll try it and see, we might have to adjust it. And then I want to make my scale to be 10, which means it's increasing by 10 to get to 50. Let's graph it and see if we're able to see the parabola. Notice that we're able to see the parabola. Okay, so this is a pretty good window. Your window is not going to always be the same as your neighbor's. Okay, so just as long as you're able to see your parabola and it's a reasonable X and Y axis there, then you should be good. So let's go back to window and let's write down what we put. So our X min is 0, our X max is 50, and then the X scale is 10. The Y min was 0, Y max is 50, and then the scale is 10. Okay? Alright, so from here, I want you to label your X and Y axes, and we're going to start graphing it. So, here's our X axis. That's representing the number of yards from the goal. Okay? Look at your table on your X axis. We're going from 0 to 50, increasing by 10. So 10, 20, 30, 40, 50. Okay? Alright, now our Y represents the number of feet the ball is above the ground. And then notice on your window, so whatever your window says is how you're going to graph it on your paper. We're going from 0 to 50, increasing by 10. So 10, 20, 30, 40, 50. Okay, so from here we're going to just sketch it. Let's look at our graph on our calculator. Now we already said the x or the y-axis or the y-intercept was 6 because that's our c. And we're increasing by 10, so we know it's a little below there. I'm just going to sketch. Okay, it didn't have to be perfect. We're just sketching it there. Okay? All right, so we graphed it. Now let's start answering some questions. It says, how high is the ball when it crosses or it's 30 yards from the goal? How high is the ball when it's 30 yards from the goal? Okay, so don't put crosses here. Okay, so notice if you look back at your graph, our x was the number of yards from the goal. So we are given the x value, x is 30. We're trying to find what y equals because it says how high. Same thing on B, we're given x. X is 15, we're trying to find our y. Same thing on C, x is 5. We're trying to find our y, which is how high it is above the ground. Okay, so there's several different ways of doing this. You could go to your table on your calculator and see if you can find it there, but there's also another way that you can do it. We're going to do second calc or intersect. So if you turn your calculator on there, so second calc or trace. And then we're going to go to number 1, which is value. So if we just press enter there, it should say x equals and it should be blinking. We can type in any x value, so I'm going to say x is 30. Press enter, and then it tells you what your y is, and it actually also shows you on your parabola where it's located. So our y value would equal 35.25. We're talking about the y, which is the number of feet it is above the ground. So let's label that as feet. Okay? Alright, so you can either repeat that, or you can, since you're already there, you can go ahead and type in 15, press enter. So when x is 15, let's round to 2 decimal places. Our y will equal 42.56. That's also the number of feet it is above the ground. Again, it also shows you on your parabola on your calculator where that's located at. And then the last one, type in 5, press enter, and that would be 23.06 feet. Okay, so anytime you're given x and you have your quadratic plugged into y equals, you're going to go second calc number 1, choose value, and then you can just type it in. Or you could also go second graph, look in your table and see if you're able to find. So notice at 5 it was 23.06. So you can find it in your table or do second calc number 1, which is value. Okay, so let's look at the back. It says, where is the ball located? That's what we're trying to find. When it reaches a height of 15. So this time, height, remember, is your y. So this time we're given the y value. And we're trying to find the x. Because we're trying to find where it's located. Okay, so the number of yards from the goal. Alright, so anytime you're given y, what I will do is we will plug in our y value into y2 on the calculator. So if you go to y equals, keep your quadratic in y1. We're going to type in our y value, which is 15. If you graph it, it should be a straight line when y equals 15. Notice that it crosses, your parabola crosses that horizontal line at 2 different places. So you should have 2 different answers. Now the reason why it's going to be at 2 different places is because the ball is going up and it reaches 15 feet, but then when it comes back down it also reaches 15 feet again. Okay? Alright, so we need to find both. So we're going to use second, mark this on your notes, second calc. We're trying to find where they're intersecting that horizontal line, so we're going to use number 5. So second calc intersect is 5. Move your cursor to whichever one you want to find first. So your intersection point. Get as close as you can. Press enter 3 times. And then it should tell you your x when y is 15. So that would be at 2.46 yards. And then there's another one. So second calc intersect. Move over to the other one. This is not very fast. And so your other one would be at 37.54 yards. So 2 different places, because as the ball goes up, it reaches 15 feet, and then when it comes back down, it also reaches 15 feet. So you should have 2 answers there. So if you're given the y value, plug it into y2, and then find where it intersects, the parabola intersects that horizontal line. Okay, so number 3, if nobody catches the ball, approximately where on the field will it land? So if nobody catches the ball, that means the ball hit the ground. So remember, your y is how high it is above the ground. So if it's on the ground, that means your y equals 0. We're trying to find where on the field, how far it is from the goal line, okay? So that means if y is 0, that means you have an x-intercept. So basically you're trying to find your root, okay? So let's go. Let's do second calc. We're going to choose number 2, which is 0. We're going to find the left side would be above the x-axis, the right side would be below, and how you know you're below is the y value is negative. And then press enter. Now remember, we talked about e to any negative power is 0. So that x value would be 41.48 yards. So if the height of the ball is 0, that means y is 0. So you're going to be finding your 0 roots x-intercept. Okay, so all those mean the same thing. So second calc number 2. You could also plug in that 0 for y2 like we did on number 2, and then find their intersection. That's the same thing. There's our answer there. Okay, so at number 4 it says, what is the maximum height of the ball? Anytime we're talking about maximum or minimum, we're talking about the vertex. So I'm finding the vertex, but notice it says height. The height, remember, is your y. So the y value of your vertex is what you're trying to find. So remember, vertex, second calc. Since we're talking about a maximum, we're going to choose number 4. So second calc 4. You need to move your cursor on the left side of the vertex. Press enter, and then the right side of the vertex. And then press enter again. So the vertex, the x value is 20, because 19.999 is 20, and then the y value is 45. Since we're looking at the maximum height, it would be 45 feet. Make sure that you're looking at your y value there. Okay, so 5, it says, where did the maximum height occur, which would mean how the yardage, okay? So that would be your x value of the vertex. So if you look at your calculator, the x value was at 20 yards. Okay, so we're going to find the domain and range for this problem. Okay, so domain, remember, represents x, your range represents y. So I'm going to go ahead and turn back over to our graph. Let's look at our x-axis. The smallest x value that we are using is 0, because that's 0 there, and it's going all the way to this point here on the x-axis. That is your root. Okay, so let's look back and see what our root was that we found when the height was 0. So it was 41.48. So that's 41.48. So our domain would be in between 0 and 41.48. I'll let you choose whether you want to write it in interval notation or set notation. Okay, so you can either do x is in between 0 and 41.48, and it will include those, or you're going from 0 is your smallest, to 41.48, and it includes both of those. So I'll let you decide on whichever one you want to, or whichever way you would like to describe your domain. Okay? Alright, so the range is your y. Let's look back at the graph. The smallest y value here is also 0 because it has to, the height is 0 at some point whenever it reaches the ground. Okay, so it's from 0, goes all the way up. We need to find that highest height there. Okay, remember that's your maximum, which is your vertex. So we found that. It was 45. So we're going from 0 to 45 on the y. So again, you can either use set notation, it does include 0 and 45, or interval notation, you're going from 0 to 45, and it includes it, so brackets. Okay, so we were applying to the real world situation, dealing with quadratics and having to find our missing pieces there. Okay, so tomorrow we will actually get into another real world type situation dealing with parabolas and quadratics.